Now, speaking of interesting geometry, that's a triangle. What are some other cool shapes that we often like? Echelon. What's your favorite Platonic solid? Yes, I'm limiting you.
I don't really have a favorite. I don't know. All five.
All five, okay. I got triangles. So we got a triangle which can turn into tetrahedron. You have your cubes, which are the faces of the square. Oh God. See, I thought making these things back in the day was actually really cool because depending on how you looked on it, it seemed to move. But then I always got lost track of it. All right, and then we have, oh God, now I'm going to run into problems. Now, okay, no. Octahedron. I can kind of draw that. Oh God, I'm trying to remember. I can cheat because you can't see the other side depending on how I present it. There we go. And then, okay, now I'm getting, okay. So, I should have thought before I started speaking. My drawing skill, oh God, I'm building the worst house in the world. Okay. You finish it off and then you have the icosahedron, which is a whole bunch of triangles arranged in a particular way. I'll do an overlay. But I started talking about it. I meant to go in a different direction, and then I committed to the bit. So, okay. So, rather than that, we'll skip. How about a circle? It's where I meant to go before I boxed myself in, literally. But we have a circle, which is basically our essential 3D equivalent, or in some cases 2D equivalent of a sphere. Because apparently this two-sphere, you have the ability to do very interesting things with that. Do I really understand what those are? No, we'll get into that another time. But what the claim is, we have what we formerly called the hyperbolic vortex equation. Now it's the hyperbolic Mobius connection equation. I'm personally particular to the hyperbolic Mobius partition function. Per se, I think it flows very well. And personally, it might be accurate because we're describing how we decompose spherical forms. I say those words because I think that's the most accurate at this time, because I could say bodies. Bodies include, well, to be fair, we are talking about physics, so we would expect to have some physicality, but I'm happy with forms. But that equation itself, 1 over x plus x cubed divided by 2 pi. So what is this? All right. We got whatever thing's happening, 1 over that. We got the thing itself. We got the thing cubed, so almost a volumetric thing there, and you're doing a twist. So that equals I raised to the I. That's all raised to the negative pi divided by 2, and we set that equal to a lambda difference, so we subtract out the blank mass gap. Okay, I think that's on the t-shirt here. Why? I heard Professor Kako a number of times saying, there existed equation. I don't know anything about a God equation, I just know this was a pretty cool equation, and I'm like, well, let's put it on a t-shirt. Sounds good.